Math Blast 32. I can compare numbers in standard, unit, and expanded form. Use the correct relational symbol to make each sentence true. 192,945 is being compared to 129,495. Those numbers are written in standard form. I'm going to compare place value to place value. So in the hundred thousands, I have 1 versus 1. In the 10,000s, I have 9 versus 2. I know that 9 10,000s is greater than 2 10,000s. So 192,945 is greater than 129,495. Next, I have two numbers that are written in unit form, 41 ones versus 6 tens. My 41 ones, to write that in standard form, I want the 41 to end in the ones place. That has a value of 41. For 6 tens, I want to write my 6 ending in the tens place. That means there are no ones. That has a value of 60. Now I can compare just like I did in the previous set. Tens to tens. I have 4 tens versus 6 tens. 4 tens is less than 6 tens. So 41 ones is less than 6 tens. For the last set here, I have each number written in expanded form. I'm going to compare these numbers in the expanded form because I see that both have 2,000s, 300s, and 5. It is this additional 40 in the number on the left that makes that number greater than the number on the right. I can apply multiplication of fractions to word problems. It takes 1/4 of a box of nails to build a bookcase. If I build 4 bookcases, how many boxes of nails will I need? Check all of this should say expressions because they're not set to be equal to anything yet. So we're going to check all of the expressions I could use to solve this problem. Then solve. So if it takes 1/4 of a box of nails to build a bookcase and I'm going to build 4 bookcases, I want 4 groups of 1/4. That would be 4 times 1/4. The commutative property of multiplication lets me know that, hey, I can flip those factors and get the same product. So 1/4 times 4 also works. I also know that multiplication can be represented as repeated addition. So 4 groups of 1/4, it's the same thing as 1/4 plus 1/4 plus 1/4 plus 1/4. All right, and we can't use 1/4 plus 4 or 4 minus 1/4 because those don't mean the same thing as 4 groups of 1/4. Now we want to see what are those all equal to. 4 groups of 1/4 would be 4 fourths or 1 whole. And again, we said all of these were equal to each other, so they're all going to have the same answer. Next, I can express a fraction with denominator 10 as a fraction with denominator 100 and add like units. Express the fraction with denominator 10 as an equivalent fraction with denominator 100. So I can see that I have 2 tenths, and I'm going to model that in our diagram here. I've shaded in 2 out of the 10 pieces. Now, in order to convert that to hundredths, I'm going to want to decompose each one of those tenths into 10 equal parts. Okay, so each one of my tenths has been decomposed into 10 parts, giving us now a total of 100 parts. And now shaded would be 20 out of those 100. So 2 tenths is the same thing as 21 hundredths. And when we take 21 hundredths and add that to 8 100ths, we get 28 100ths. On the back side, I can interpret data in graphs, create graphs, bar, picture, or line plots. Pieces of ribbon were measured to the nearest 1/4 inch. The measurements are listed below. Make a line plot representing the data. I noticed that all of my numbers are from in the ones, and then I have a 2. So I'm going to start with 1 and end with 2. So my whole that I'm representing is from 1 to 2. And since we're dealing with measurements to the nearest 1/4 of an inch, then our units are going to be fourths. So here we go. I'm going to break my whole into 4 equal parts. And since I started with 1, I can now count by fourths. This would be 1 1/4, 1 and 2/4, which I know is the same thing as 1 and 1/2, and 1 and 3/4. And then 1 and 4/4 would be 2. Now, again, we want to make these parts equal, and mine don't look super equal, but we're going to kind of fix that there, make that the best we can. And now I'm going to go ahead and plot each number. I have 1 and 1/4, 1 and 1/4, 1 and 2/4, 1 and 3/4, 2, 1 and 1/4, and 1 and 1/2, which I said was the same thing as 1 and 2/4. Notice an organizational strategy I used there was to cross the number off once I had plotted it. What is the difference between the longest and shortest pieces of licorice? The longest piece of licorice would be 2 inches. And the shortest piece of licorice, we don't want to use the 1 because there's no X above that. The shortest piece of licorice in our data set is 1 and 1/4 inch. So now I want to subtract the 1 and 1/4 inch from 2 inches. I know that 2 inches is the same thing as 1 and 4/4 inch. Minus 1 and 1/4 inch leaves me with 3/4 inch. Identify the ray below. A ray has an endpoint and continues to infinity in one direction here. So we're going to say we have ray CD. Draw ray CD parallel to line segment EF. So if I want to draw ray CD, remember I have to have C at my initial point, and it's going to go in the direction of D. So CD. And to be parallel means never ever touch, no matter how far extended. So I want to make a line segment EF parallel to what I already have, CD. So line segment's going to have points at both ends. I can call this EF. And to be parallel, I'm making all points on my ray equidistant to all points on my line segment. Draw line MN perpendicular to ray RS. So a line goes on in both directions to infinity. So I'm going to say, let's draw this one as a vertical. We could draw any way we wanted, but I'm going to draw my line vertical, and we're going to call this MN. And I want to make it perpendicular. So that means it's going to intersect in a special point that causes right angles to ray RS. So we want it to create right angles here all the way around there. And so ray RS is going to have a point at R and go in the direction of S.